Hi everyone, my name is Bob DeWitt. I'm lead developer and CTO of PoC, and this is a short video about our initial week's test results and achievements using the new Intel Creative Gesture Camera and SDK. Now, in order to explain how we've approached this, I think it's useful that I give you a little background on what PoC is all about. So for those of you that don't know us, we are building a controller interaction platform. And this is based on a principle that we call dual abstraction. This means that we're not going to try and write code that needs to be integrated in the development phase of applications. We are abstracting both the controller or interaction device and the device or application that we want to control or interact with. And all of this is based on profiles. So we will define device profiles, we will define profiles for the applications and or games that we want to control using this principle, and the underlying principle for making this easy for the end user to actually implement this is based on visual layouts and interaction mapping. Now, the key thing for this video that you really need to keep in mind is that the objective of this controller interaction platform is that the software that we are going to interact with or control will not have to be modified in any way. So this principle is designed to work with existing software. Let me illustrate this by using an example. Let's say that you're playing an MMORPG on PC. You would normally control this game with the keyboard and the mouse. Now the thing is, especially with more complex games, that you're going to have to learn and remember a whole series of key combinations, and depending on the game, if you have different types of characters, those key combinations might even change for different characters. So what we're trying to do is not only abstract this control of the game so that you could use other devices to take over, so to speak, the control of the keyboard and the mouse, but also to use more simple and intuitive means of controlling the game or interacting with the game. Now, prior to our contact with Intel regarding this project, we had already constructed a framework that allows you to use devices that users typically already own to interact with or control applications or games, even if those games were not designed to be controlled in such a manner. Now, this includes smartphones, tablets, and game controllers. What we've done for this specific project is look whether we could integrate the gesture camera as a controlling or interacting device into this architecture and principle. The results of our first week testing are extremely encouraging. We received the hardware on the 23rd of October, so we've had a bit more than a week now to play around with the camera and the SDKs. The first thing we did after some experimenting and checking out the SDKs is we built a C#.NET gesture camera engine, which basically abstracts the events that come out of the camera so it can be integrated into our framework. We did this based on interfaces that communicate events for gestures and movement. We then mapped some of the camera events that were passed by this engine to our existing virtual machine engine. The VM is basically what translates controller or interaction events into things that the application that you want to control will understand, such as mouse movements or keystrokes. And then as a next step, we built a rudimentary module system so that we could apply this principle to some of the demo games that we're now going to show you. We've created 3 demo modules based on our still very rudimentary engine, of course. 2 of them are Flash games that you can just load in a browser from the internet, and one is to interact with a YouTube video player. The important thing, as we already mentioned, is these Flash games and the YouTube player are used as is. There were no modifications required to the games or the YouTube video player. The first demo module we built was based on the Flash game Simon Says, which is a simple mouse-based Flash games that you usually play within a browser. What we did was we mapped the hand motion from the camera to press areas within the Flash movie. And as this is the first one we built, we obviously first needed to build the framework and the bridge between the camera class that we constructed and our VM. But once that was done, the actual demo module using this Flash game was built in less than 4 hours. The second demo module we built is based on a simple mouse-based Flash game called Samurai Fruit, which is a fruit slash game which is used in several other demos of competitive cameras that are appearing on the market. What we did here was we just mapped the hand motion to mouse motion. Because it was very simple, it was built in less than 2 hours. But as you'll see, the use and control of it is very intuitive and natural. The final module we built this week to demo is around the standard YouTube API and player. We wanted to do something with gestures, as the two previous demos we did were focused mainly on motion. So what we did here is we mapped gestures to things like a volume and playback control. Again, because the framework and abstraction layers already existed, we were able to build this very fast.
We also have some feedback for Intel, which we will provide in a detailed document, and this will concern initial findings, etc., about the camera, the SDK, mainly from a developer point of view. Thank you very much for taking the time to watch this video.